Alright, so in this video I'm going to show you guys how to add Bluetooth to an Audio 10 CD radio. This particular one is an Alpine NF2910, I believe it is. Yeah, I put Kapton tape over the important labels so that they wouldn't perish over time, especially the code card. That is crucially important. It's actually not screwed together because I'll take it apart briefly to show you guys what's going on. And again, just before I start, if you're the kind of person who adds a Bluetooth radio adapter thing that sounds like complete garbage and thinks this is equivalent, then please fuck off, hit the dislike button so I know you were here, leave a hate comment or some crap, and get the fuck out of here. Right? So this is basically integrating Bluetooth 4.1 inside the radio in a very, very elegant way. So whilst maintaining the functionality entirely. So this mod is completely transparent unless you know how to activate it, and that's also very easy. I applied some talcum powder to these buttons. They usually go soft and wear off. So let's start it up. And I'm going to have to input the code, so I'll speed up through that. Alright, so on the back I have this little makeshift antenna that helps me get Radio Bob and Antenne Frankfurt. That's the only shit that this is capable of receiving. On the back end I'm just feeding power into the DIN connector. I've connected the ground to chassis ground so that in case I swap the polarity I just have a short circuit across the supply so I don't fry this. Now there's a speaker connector, and I'm also connecting the ignition pin. More on this later. So I think our antenna fell out. Anyway, so basically this works just like a normal radio. But something cool happens when you turn the volume all the way down, or mute the channel, but turning it all the way down is better. And might see that there's a little light going on over there. And if we go over to the iPad, we should find the radio, connect to it, and we can now start playing music. So the volume now on the stereo end is maximized. So basically full volume here is full volume, the most this can put out. And the moment you turn the volume one click above 0, it disconnects, turns off the Bluetooth module completely. So we'll see this disconnect, exactly. And basically the Bluetooth module is completely off. You'll never know it's there. You can put CDs in, it works, it's fine, like it wasn't there. And turn it all the way back down. And now it's going to connect to this automatically this time, hopefully again. And it did. And you just hit play on your phone or whatever. And again, last time a lot of people said in the comments that, oh yeah, no, this works like a Faraday cage. Sorry, you know what a Faraday cage is? Like it's this cage thing. Yeah. Dude, yeah, first of all, there's a bit of an opening here that is transparent. And range-wise, it really works fine. So let's take this. And I'm running out of room to back into. And so if your car is this big, then you probably, yeah, I don't know, should get a smaller one. Not really funny there. Anyway, so yeah, basically, let's see if it turns off. And it should automatically, at least on iPhones, pause your music, so very cool. And once it's on Bluetooth mode, so it's waited to pair. If you turn off the radio and turn it back on, it actually remembers the 0 volume, so it doesn't go to a default value, which is also very, very useful. So basically, if you want to use this just as a Bluetooth, so mainly as a Bluetooth radio, you You just leave this all the way down all the time. When you go to start your car, it's going to start in Bluetooth, power up the Bluetooth module, connect to your phone, and work exactly as you'd expect it to. Alright, so now that that is out of the way, we could actually tear it down and... Right, so to take such a radio apart is not really that complicated. You have to take 2 screws on each side off, and I think there's one here and one here. So after that, you should be able to just prise up the top cover. This is quite a tight friction fit. Alright, the radio unit is also screwed in with 4 screws. These are also out on mine, so you can just pop this out. It's going to be a bit reluctant, right? It's quite tight in there. Basically, you want to push it up over here and over this lip that you can see, and then the back will also give way much easier. The front plate will try to come off, so we can actually take it off. Why not? So this looks like this. Put that over to the side, and now we can actually look at the root of the problem, so to say. So exactly, so this is how the Alpine version of the radio looks. Again, Alpine MF, what is it, 2910. Have no idea how the Becker ones look inside. I wouldn't assume too different, and this method is quite robust in that it should accept any topology of radio, not necessarily a Mercedes radio. So we have a few things going on over here, and to show you those, I will also remove the amplifier board. So there's a board here, this one, that contains the amplifier chip and the heatsink and the DIN connector on the back. So in order to pop this off, you'll want to gently and easily rock this back and forward. Back and forth, I think I wanted to say. And then it's going to catch on the antenna. So you want to bend it this way. And let's see. This is always a bit tricky. Alright, and it's off. Okay. So if you take this motherboard out, you'll see that the pins on the back are very nicely labeled. They're also labeled on this one, but it's quite a bit worse. So kudos to Alpine for writing the pinouts. Okay, so what we have here is the Bluetooth module that I've screwed in with unfortunately only 1 screw because I just can't be bothered to drill a second one, and it really isn't necessary. I mean, this isn't gonna like have any sort of rotational vibration type of deal going on, so yeah, that should be fine. We have the signal wires, so this is ground, which is chassis ground, and which also is audio ground, left and right. And this actually bridges the front and rear channels. So if you can see, pins 1, 2, and 4 and 5 are bridged together. So you actually shouldn't have any fader front or back, because this should be quite weird on the TEA Philips audio controller chip. Shouldn't do good to it in any case. Okay, so I've unanimously decided to go ahead and cut the handheld crap out, and went ahead and did a little presentation for you guys. And yeah, for myself as well, right? Because when I'm going to do this in the future, I'm not going to remember any of this shit. So yeah, let's get started. This is the back of the amplifier module. And as you can see, it has a TDA 7385 on the Alpine version. There's also a Becker built one, and there's actually, so there's 3 ones I've seen. There's one that's built in France that has a removable left button zone, kind of, so the few buttons around the volume are on a little board that actually comes out for extra security. There's one built in Hungary, and I think that might be also Becker, although I'm not sure. It might be Alpine. And then there's an Alpine one that's built in Japan, and this is this one. This has the nice pinout, right? But in this area and this area, they've ran out of space, and it's completely crap. Anyhow, so the first thing you'll want to do is cut this trace off,
and this goes to pin 25, 24, 22 of the TDA chip, amplifier chip. Basically, this will make it impossible for the radio to mute the amplifier. This has fairly insignificant side effects, so even if you, yeah, I don't know, it's not that bad. First of all, you can reconnect it, and even if you don't, I mean, the noise floor of this amplifier, right, given that it's an AB amplifier and specified in the datasheet for high-end applications, it's fine, right? I mean, even if it's not muted, it's really not bad at all. So what this will allow us to do is detect when the amplifier is muted and actually control the Bluetooth module as I've showed in the intro. But anyway, this aside, let's go on to the Bluetooth module, and this is it, the green board with the blue board. This is what you'll be buying. These range from 11 euros to 20 if you want to buy them locally. This is a 12 volt model, so this Morn Sun DC-DC converter here. This is an isolating converter. So basically there's no galvanic connection between input and output. You put plus and minus here, 12 volt, and you get plus and minus 3 volts, and they're not at all connected because this Bluetooth chip, the 8645, draws insanely large peaks of current, right, to operate the radio, and throws a lot of garbage out onto the rails. So you need this to separate to keep the noise on the supply local to this board and not have it feed into the radio. And piggybacked onto this with some silicone is another DC-DC converter, this time not isolating. This is a buck converter. These are very, very nice. So the ones with the small chips, we'll go into more detail later. And this will be powering this board and ensuring that it never gets more than 12 volts, because a car's voltage might even go above 14.5. And the problem with these Morn Sun DC-DC converters, I checked the datasheet, they're very, very picky. I mean, I haven't had the balls to test one because it's a pain in the ass to get them, and they're quite expensive, and I haven't yet created a stock of these. They say 12 volts plus minus 0.5 or something ridiculously low, so they're very specific about the voltage. So I really don't want to go shoving 14.5 or 15 volts into them. Another thing that happens with these is, I think by design, they follow the input voltage. So if you give them 12 volts, they're going to output 3 volts, right? But if you give them 10 volts, they're going to output 2 volts or some crap. I don't know exactly the exact relationship, but they do follow the input voltage. And this can actually be used, right? If you're running this off of a battery pack, you can detect the battery voltage with the chip and send it back to the phone, and it should be linear, right, with the voltage of the pack. So you could actually use that. I never did though, so meh. But anyway, keep that in mind. So what this does basically is, if we have 12 volts on the input, then it's going to give out, I think, 11.5 or something, so not too big of a drop. And if we give it anywhere up to 32, it's going to give 12, a very rock steady 12. So I was turning the knob as fast as I could on my supply, and the output voltage is rock steady. So these chips, the 8-pin ones, incredibly good. And on top of this, over here you can see there's an unused pad, because at the time of the photo I hadn't thought of using the enable. They actually do have an enable pin, which, again, more on this later. Let's first of all see how we connect the input to the Bluetooth module. By the way, if anyone's wondering, these wires are for the programming, and it's a pain in the ass to solder to these super small connectors, so I usually solder some solid core wires just to have them easily connectable to a program. Alright, so basically this is another view of also a poor one at that, of the buck converter. So I'm definitely going to put some links in the description for them. You definitely want to avoid the modules that have the larger chips. So you want the ones with the tiny chips, because these go up to 30 volts, the other ones do not. The other ones struggle above 12 even. And this one does have the enable pin, right? So we definitely need this in our case. So yeah, this is a rough diagram. There's going to be 3 connections for power on these Bluetooth boards, and you're going to have 2 grounds. One of them basically bypasses the DC-DC converter, so you definitely do not want to go connecting on this, because you'll basically be shoving whatever voltage you have, 12 volts across the Bluetooth chip, and that expects 3.3, so it is not going to be quite happy. So always connect to the, I mean always, do check, right? But on these this model of boards, it's the corner connection, the top corner, outermost connection is the ground for the morn sun. But again, you can check that out. So yeah, this is basically what we're doing here with the buck converter. And now let's discuss where we're going to connect this. So where we're going to get our car voltage from, basically. And this is again a more annotated version of the amplifier board. And let's zoom in on the top right corner and pop up this pinout. So this here, these 8 pins are these ones here, our bank A, and we're going to be tapping into pin 7, which is this one. Again, this is flipped, that's why they don't correspond. Pin 7 and pin 8, right? So this is 12 volts whenever you have turned the key in the car. So you pop the key in, turn it once, and this already gets energized. And you turn it again, and all the fans come on, and then you turn it again, and all the engine comes on, and all the crap. This will stay on. It might actually go down and then up again, but it's while you power up the engine, but it's still fine. So you actually will not have Bluetooth in the car when the key is not present or turned on, right? So that's a small drawback. I mean, you could wire it otherwise, just connect it to plus 12 volts, right, to battery, but I don't know, I've always done it this way, and I'm quite satisfied because this has the advantage of cycling power to the basically powering the Bluetooth module up when you start the car up. And that's good because these chips at power up attempt to connect to the last connected phone. So that's very good, right? You get in the car, boom, turn the key on, it's already connected to your phone, hit play, you're done. All right, so that's how the power for the Bluetooth module is wired up. And yeah, exactly, so these 2 pins. Initially I didn't figure out how to get the cursor to appear on the screen, so I put the arrow there. Alright, so yeah, moving on. The control logic, right? So I've showed you guys that when the volume is 0, the Bluetooth module is turned on, and when it's not 0, it's turned off. And there's a slight issue here. So I would have very much fancied the amplifier to be controlled the other way around, right? So the mute to be active high, not active low. So this basically goes to chip 22, the one I showed you guys earlier. And this pin gets 0 when the amp is supposed to be muted. So when the volume is 0, this pin gets 0 volts. And when the volume is not 0, then it gets 5 volts. The problem is, fucking shit, this buck converter is exactly the opposite. So if you leave the enable pin floating or set it to 5 volts, or I think you can even give it way more, then it's on, and when it's 0 volts, it's off, right? So we want it to be exactly the opposite, because when we mute the radio, we have 0 volts, but with 0 volts, we want to turn the thing on, right? So we need something over here that inverts our signal. And fortunately, you only need like a resistor and a transistor, and the circuit is very simple. So I mean, it's not that big a deal, right? I mean, it's still a quite major pain in the ass, but it's definitely doable. And this is how the circuit looks like. So we have this transistor, and you can check the data sheet. So what I got was a 2N3904, and these are extremely cheap, and you can find them at any electronics store or buy them online or whatever. So I had a few of these lying around. These are NPN transistors, so they're drawn with the arrow here. If you have the arrow pointing inwards, those are PNP. Just as a quick note. Exactly. So this is actually the signal coming from the stereo, right? So the stereo is going to give 0 volts when it wants the amp muted, and we want that to turn into 5 volts. So the 0 volts will actually turn this off, and this will basically be not connected. So we'll have 5 volts flowing through this resistor up to our enable pin, thusly enabling the output. When it doesn't mute when it wants to play the radio or CD, it gives 5 volts here. These 5 volts turn on this this transistor, and this immediately connects this to ground, right? So some current will try to flow, right, from 5 volts and lift this point up to 5 volts, but very little current will pass because of this resistor, and all of it will be flowing to ground this way because it's going to be the path of least resistance. So this is how this works. Quite straightforward. I created a little flow chart, right? So you power the thing on. If the volume is set to 0, and it actually remembers the volume after power down, right? So if the volume's 0, the Bluetooth is on, and the radio the radio is actually playing in the background, so it's showing you the whatever RDS data is on it. So the radio station, you can change it, whatever. Just that it's muted, right? So it doesn't. It's in parallel with the Bluetooth, but it doesn't affect it because the level of it is 0, right? And this happens infinitely many times, right? Obviously, it's a more or less analog circuit. Once you set the volume to something that's not 0, we're going to turn the Bluetooth off immediately and have the radio and CD work normally. And the reason why we do this, right, why we need to, I'm not sure if I said this already, but anyway, is because when the Bluetooth is on, even if it is paused, it actually shorts its outputs to ground, kind of. So it will attenuate whatever signal is coming from the radio and CD quite a lot, right? So we want it to be completely powered off, just so it can leave the left and right channels floating and controlled by the radio or CD. Okay, so before we talked about the 5 volts, right? And in this 5 volt, like we're going to take this from this spot here. This is a linear regulator, which I actually shorted to ground. Holy crap, I tried to measure it and I forgot my probes in the amp setting. So I actually shorted this out for like, should be like less than 200 milliseconds, because I did realize it when I heard the little pop. And it's still fine, so that was a close one. And so you get your 5 volts from here. Those were the wires that you've seen earlier. And yeah, I think now we can move on to the actual signal. So the Bluetooth board has 3 outputs. It's a single-ended stereo setup where we have ground, which again is galvanically isolated from this ground, right? We will actually be connecting it at some point, right, through the chassis and shit, but it's going to be fine that way though. So exactly, we take the left channel and we bridge it to both front left and rear left. Initially I tried putting some resistors here and here, right, just to limit the connectivity between the channels in case you want to have a fader to rear or to front or something. Although I actually never use that, so the problem is that it used to attenuate the signal quite a lot, so it was unacceptable. So I ended up just, I mean, this is for my father, so I mean, he's never gonna fucking touch the faders. So yeah, it's, I don't know, I've never had the balls again to check what happens if you go full front. I mean, theoretically it should just not drive the rear and then it's fine, but if it drives them less, then I don't know, you might get some weird effect going on. So I don't know, I just don't do it. So this is actually the second and only other drawback, right? So you have to have the key in and turned to get the whole thing to work, and you can't use the faders. These are the only drawbacks of the system, which, to be honest, are quite acceptable in my book at least. Alright, so yeah, this actually goes to audio ground. There's also a signal ground or S ground, whatever the fuck S means. And I don't know what the fuck the Japanese mean or the datasheet means from ST, right? Because that also has S ground. Maybe someone can explain in the comments. That's actually not driven. If you put your signal to S ground, left and right, nothing happens. So you have to use the chassis ground, which is also audio ground. Yeah, exactly. And now let's zoom into the section we're going to be poking in. And I've decided to connect everything to this board instead of the main board because it's easier to just unplug it and work on it. So yeah, this is basically the pinout, right? They've tried, I mean, the Japanese did try to write it on the board, and I appreciate it, but it's really not understandable, right? So our RFF, maybe yours will be better, but mine was not understandable. So it says ground here. This is absolutely not ground. I forget what it is, but it's not ground. Anyway, so yeah. What was it? Yeah, rear right, front right. Ignore this. Rear left, front left, and audio ground. And this is the other side where the muted signal can be tapped into. I've actually tapped into it on the bottom side of the board, the close to the connection I cut. I actually don't know why I did that, but anyway. If somehow you rip that pad off, it comes off over here. And that is pretty much all there was to this. And if you have any questions, or leave them down in the comments. And yeah. Thanks for watching.